Hi friends, today topic is Python operators. Python operators.
Welcome back to The Explainer. Today, we're prying open the Programmer's Toolkit to get a good look at the most essential tools in Python, operators. Honestly, these are the absolute building blocks for pretty much everything you're
Python
ever going to
core
write.
tools.
So let's start at square one. What in the world
Operators.
is an
A
operator?
symbol that
Well, it's
shows
just a symbol that tells the computer to do
performs
something.
certain
Like
operations.
adding numbers or checking if two things are the same. They're basically the verbs of the programming world.
Symbol that
To really get a handle on this, we're going to imagine we're unboxing a brand new toolkit. We'll start with the everyday tools you'll use for math, then move to the precision gear for making decisions, and then check out some of the more unique gadgets. And of course, we'll read the user manual so we use them all correctly. Okay, let's pop open that first tray in our toolkit. These are your workhorses, the tools for doing math.
everyday tool.
If you're writing any code at all, trust me, you'll be reaching for these constantly. A lot of these probably look super familiar, right? You've got your plus, minus, multiply, divide. But Python also gives us some really cool, more powerful ones, like floor division for when you only want the whole number part of a division, or modulo, which just gives you the remainder, and even exponent for calculating powers. Let's see it in action. It's super simple. We make a variable a equal to 10 and b equal to 2. We use that little plus operator between them, and, well, you get exactly what you'd expect, 12. Nice and easy. Now, this is where it gets kind of cool. Python actually has two different ways to divide. A single slash gives you what you'd expect from a calculator, a decimal result, which we call a float. But the double slash? That's floor division. It chops off everything after the decimal, giving you a clean whole number, or integer. It's a small detail, but it gives you so much more control. All right, on to the next set of tools. These are the ones that let our programs, well, think. They let our code compare things and make choices. This is where your program stops being just a calculator and starts to feel alive. This is really the heart of logic in programming. So, how does code actually make a choice? Well, it all boils down to asking a really simple question, a question with a yes or no answer. For example, is the number 10 less than the number 20? And in Python, you can just ask that question directly. You use what's called a relational operator. In this case, that's the less than symbol. We're literally asking the computer, hey, is this statement true? And here's the magic. Python answers back with a Boolean value. Since 10 times is less than 20, the whole thing evaluates to true. If it wasn't, it'd say false. And that simple true or false answer is everything. It's the signal your program uses to decide what to do next. So these decision-making tools really come in three flavors. You've got your relational operators to compare values. You have equality operators to check if things are exactly the same or not. And then you have logical operators, which let you chain questions together, like asking if one thing is true and another thing is also true. Okay, time to dig a little deeper in our toolkit and look at some of the more specialized gear. You might not use these every day, but for some very specific jobs, they're absolutely the only tool that will work. And they are incredibly powerful. First up, membership operators. Ever need to know if a specific word is inside a sentence or if a number is in your list? Well, the in operator is your best friend. Here, it's checking if the word Python is inside that longer sentence. And yep, it is. So it returns true. Okay, pay attention, because this one is a bit tricky but so important. The double equal sign checks for equality. It asks, do these two things have the same stuff inside them? Here, both lists have the same words, so it says true. But the is operator asks a different question. It asks, are these two things the exact same object in the computer's memory? And since we made two separate lists, they aren't. So is returns false. Getting this difference is a huge level up moment for any programmer. And finally, we have the really specialized stuff, bitwise operators. These are for the power users. They let you get down to the nitty-gritty and work with the individual ones and zeros that make up numbers inside the machine. It's some seriously low-level, powerful stuff, but not something you're going to need most of the time. So having all these awesome tools is great, but what happens when you try to use more than one at a time on the same line? This is where we need to pull out the user manual. We need to know the rules, the order of operations. So take a look at this. We've got addition and multiplication here. So what's a computer to do? Does it do 3 plus 10 first to get 13 and then multiply by 2? Or does it do 10 times 2 first? The order completely changes the final answer. And the answer is 23. This tells us that Python did the multiplication times before it did the addition. And this isn't random guesswork. It follows a very strict set of rules called operator precedence. You might remember something like this from math class, right? Python has a very clear hierarchy. Parentheses always win, they go first no matter what. After that, exponents get top priority, then multiplication and division, and at the very bottom of the list are addition and subtraction. This makes sure your code is predictable and always works the way you think it should. So we've gone through the awesome tools that come standard in Python's toolkit. But here's the best part. You're not limited to just those. You can actually import whole new toolkits, called modules, to give your code even more superpowers. A classic example is the math module. You just type import, bottom of the list are addition and subtract, top priority, then multiplication and division, and at the very bottom, no matter what. After that, exponents get top priority, then multiplication and division, and at the very bottom of the list are addition and subtraction. This makes sure your code is predictable and always works the way you think it should. So we've gone through the awesome tools that come standard in Python's toolkit. But here's the best part. You're not limited to just those. You can actually import whole new toolkits, called modules, to give your code even more superpowers. A classic example is the math module. You just type import math at the top of your code and bam! Suddenly you have access to all sorts of advanced math functions. Here, we're using its square root function to find the square root of 16 in a snap. And that's all a module really is, you know? It's just a file full of pre-made tools that someone else built for you. They let you do incredible things without
A module is a collection of functions, variables, and classes. A module is a collection of functions, variables, and classes.
having to reinvent the wheel every single time. It's how you can expand Python's abilities to do almost anything you can imagine. And there you have it. You've just unpacked the whole starter kit. From doing basic arithmetic to making your code smart with logic, these operators, they're the engine that makes everything go. Really understanding them is your first big step
You are just unpacked the fundamental building blocks of Python programming.
to mastering Python. We've laid out the tools, we've read the manual, the entire toolkit is now yours. So the only question that really matters is, what are you going to build first? Thanks for tuning in.